Hey everyone, my name's Eva and I'm one of your Come 350 TAs, and I'm going to be going over how to convert from a Sawhorse projection to a Newman projection, and specifically how you can use your model kit to help get a better sense of the 3D aspect of that. So to get started, we're going to work with the example of this kind of ugly looking molecule. So we're given it here in the page as a Sawhorse projection. And let's say we want to draw the Newman projection looking down bond 2, 3. So here's carbon 2, here's carbon 3. This is the bond we're going to look down, and we're going to put carbon 2 in the front, carbon 3 in the back. So you can imagine that if this arrow is your eye, it would be right here, okay? So to get started, I want to get this looking a little bit more like something familiar that I know how to work with, and kind of start to simplify the structure so I can really focus on what's going on at carbon 2 and carbon 3. First thing I'm going to do is I'm going to rotate this, and I want to put the bond that I'm going to look down, so in this case, the bond between carbon 2 and carbon 3, right flat in the plane of the page. So I'm going to rotate this molecule, right? So I am just looking at this nice flat line that's the carbon 2, carbon 3 bond, and I'm going to focus in on that and try to simplify everything around it. So we see that we have a lot of carbons in this molecule, and a lot of them are numbered, but remember that for alkyl groups like methyl groups, ethyl groups, isopropyl, tert-butyl, you can abbreviate those. And when you're working between Sawhorse and Newman projections, it can be a lot easier to use those abbreviations when you're going through the conversions, because there's a lot of stuff on the page, and it makes it easier to keep track of things. So I'm going to go ahead and do that. What's labeled carbon 1 right here, right? That's just one carbon, so that's going to be a methyl group off of carbon 2. What's labeled carbons 9 and 10, that's 2 carbons, so that's going to be an ethyl group off of carbon 2. I'm going to go ahead and delete and change this. Oh man. Drives me a little funky for me right now. All right, there we go. So right, that ethyl group, that's 2 carbons coming off of carbon 2. So right now I have 3 things that look a little more manageable off of carbon 2, a methyl group, a chlorine, and an ethyl group. So moving on to carbon 3, hydrogen and fluorine, can't really simplify those, but I have this huge thing coming off of carbon 3. And remember this structure with my 3 carbons all coming off of the same carbon, that's going to be a tert-butyl group. So I'm going to go ahead and delete that and rewrite it as TBU at carbon 4. All right, so this is looking like something a little more familiar and manageable, right? As we convert from Sawhorse to Newman. We really isolated those 2 carbons, that bond we want to look down, and now we can kind of say, okay, I'm looking right here, and I'm going to turn this molecule around and put it into a Newman. This is where I think it's really helpful to use your model kit. So I'm going to stop sharing my screen and show you what I like to do in this case. Okay, so here are 2 carbon atoms with a bond between them from my model kit. And these are going to be the 2 carbons and the bond we're looking down. So this is going to be carbon 2 on my left, your right, I believe. And this is going to be carbon 3 on my right or your left. And what I like to do is I am going to put 3 things on each carbon, right? Because I have 3 different species on each carbon. But again, instead of like building a whole ethyl group or a whole tert-butyl group on each carbon, I'm just going to use different colors from my model kit to represent different groups. And you can do this with any model kit. It's always okay to repeat colors if that's something you need to do. Great. So now I'm going to have carbon 2 here, carbon 3 here. And so going back to my example molecule, right, if I have carbon 2 here, and we're looking at this from the side, right? So we're looking at the side of the carbon 2, carbon 3 bond. I have methyl sticking straight up on carbon 1. And then I have chlorine going away from me or coming toward you. So it's dashed in the page. So that means when I hold up my model kit, I'm going to put it going away from me. So I know it's a little confusing because of the video. So our wedges and dashes are going to be reversed, but I want to show you how I would do this because you'll be looking at your model kit when you actually do this. So if something is dashed on the page, that means it's going away from you when you build your model kit, right? And that means I have the ethyl coming toward me when I build my model kit. Moving on to carbon 3 over on this side, I'm going to go ahead and say yellow is my tert-butyl, and I'm going to put yellow straight down. So I'm going to rotate that a little and get that. And then I have hydrogen. Hydrogen's going to be green, right? Hydrogen is dashed, so it is moving away from me and toward you. And then fluorine is going to be wedged, moving toward me and away from you. You can see it's white there. So now I want to make a Newman projection, and a Newman projection means I'm looking down the carbon 2, carbon 3 bond. So instead of facing the side of the bond like I am right now, I want to be facing carbon 2 and have carbon 3 going away from me. So to do that, just rotate your model kit in the air so you're looking right at carbon 2. So right now I'm looking at carbon 2 and you're looking at carbon 3, but we just did that 90-degree rotation in space to get from Sawhorse to what is now Newman, right? Because you can see we're looking right at one of those carbon atoms and you have 3 things sticking out all around it, just like a Newman projection, right? So if I were to draw a staggered Newman projection, right? You see here that we have one carbon that's right in front of you. So in my case, that would be carbon 2 right here. And then this big circle represents the carbon behind it, which in this case would be carbon 3, because that one's farther from me. And then I see my 3 groups on carbon 1 and where they are in relation to my 3 groups on, my 3 groups on carbon 2 and where they are in relation to my 3 groups on carbon 3. So this is going to make it a lot easier to go from Sawhorse to Newman and Newman to Sawhorse, right? Because if I build my model and I have a Sawhorse projection when I look at it from the side, Newman projection when I look at it right down the bond, that takes a lot of like mental gymnastics because I'm just keeping all of the atoms in one place, really visualizing this as a 3D entity and making a lot fewer mistakes than when you just say, okay, so I imagine that methyl would stay here, chlorine would go here. It's like, no, I just rotated the molecule in space, so I know exactly what's going to happen. So I'm looking at carbon 2 right now, which is going to be in front for me. And when I look at this drawing, I see that something is sticking straight up in the air. What's sticking straight up in the air on my molecule? That is going to be my methyl group. Great. And so then I'm looking at what is to my left, which would be your right. I'm seeing this blue group that I decided to call chlorine. So that is going to go on the left side of my Newman projection. And then when I'm looking to what's going to go on the right side and pointing down on the Newman projection, I'm seeing this purple group that we decided to call ethyl. So easy. Do the same thing for the back, right? And I am going to say, okay, what is pointing up and to my left? That's going to be hydrogen, the green, right? And then what's pointing up and to my right? Fluorine. And then what's pointing straight down for me is the tert-butyl. And now, if I want to double check that nothing changed, even though I didn't break any bonds when I did this, I just rotate back to the side and I see, yep, same thing. I'm still seeing the methyl pointing straight up, tert-butyl pointing straight down, chlorine's going away from me, ethyl's coming towards me, hydrogen's going away, fluorine is coming towards me. So I think using your model kit like this makes it way easier to go between Newman and Sawhorse projections and back again. Some important things to remember, right, is that you're just drawing the molecule a different way when you're interconverting between these two. So when you build your model kit, it stays together for the whole time you're using it to interconvert things. If you're using it to convert between conformers, which we'll talk more about later, remember that you're just rotating around a bond. You're never breaking any bonds or changing anything on your model when you make these. So that's another way it makes it really easy to check yourself. So I hope this was helpful. Feel free to reach out to me if you have any questions about this, or if you want to work with your model kit and practice like working with your model kit on Zoom, more than happy to meet or do another tutorial on that. Bye.